So this next chapter, it's still kind of an introduction to A-frame, but where we are actually going to start to see additional 3D objects, so additional elements that we can use in our scenes. So perhaps the most important concept in A-frame, or the word that they use, which is kind of important to know about, is this primitive words or concept. So a primitive, in kind of in the context of A-frame, it just means an HTML element which kind of has an implicit, an associated 3D geometry and some kind of characteristics. And they call it, in A-frame, they call this a primitive. And we have a number of primitives that we can use. So these primitives, you can also think of them like simple building blocks that allow you to compose a larger, more complex 3D environment. And in this example here, I'm going to first perhaps show you the preview, so the result. And this is still a simple scene, a simple 3D scene, where we have a number of different 3D objects. So we have a box, a red box here, floating. We have a cylinder, a yellow cylinder, and we have a green plane. So it looks like a carpet here in this world. And these are created with primitives. And so if we look at our source code, we see again so that kind of main structure, HTML structure, but what's relevant now in these examples, of course, is the scene, and even more important, what's inside the scene. So everything is inside the A scene. And now we have to kind of start learning how to read this source code. So because you see here that the elements or the text is formatted in a kind of specific way, and we just have to learn. You have to learn how to decode this. But so here, for example, the first primitive that we have here is a box. So a box. Notice that the opening tag, it goes all the way down here actually. So this corresponds to the auto format from Glitch, and we can write this differently, but this is just how it's automatically formats. So I think it's a good idea that you learn how to read when the text is formatted this way. It will be easier. And so the opening tag goes all the way down here, and then the closing tag is here. So this means that the box, it kind of has nothing inside. We will see later on that we can put objects inside other objects. This doesn't mean that the objects will be physically inside the other objects in the 3D world. It just means that they will be logically inside one another, so that if we move the top one, the one that's inside that will also move along with it. But it doesn't mean that in 3D position that they are not necessarily physically inside the other object. But we will see this later on. So here we just have a box, and the box has a number of attributes. So again, just to kind of make the bridge to HTML, all the attributes are written in the opening tag as pairs name equal value. And as you see here, to make it a bit easier to read, we can write each attribute on its own line, and we can even kind of use empty lines to make space between the attributes so that we can group, if we want, related attributes to make it easier to read for ourselves. The browser, it doesn't care about these empty lines or space. So here, what are we saying about this box? We are giving it an ID, kind of a proper name. We are calling this box 1. This for now, it's not very important. And then we are kind of giving it physical properties. So we are saying that the position is going to be 0 on the x-axis, 2 on the y-axis, and -2 on the z-axis. We will talk a bit about position later on. Then we are saying what is the size of the box. So a width of 1, height of 0.5, and a depth of 2. And all these units, by the way, they are, you should think about them in meters. So this is 1 meter width, 1 meter, the height half a meter, and depth 2 meters. Okay, and then we have rotation. So in this case, we are just saying that the box is not rotated. So rotation of 0 degrees on the x, 0 degrees on the y, and 0 degrees on the z axis. And we are saying that the color is red. So most of these attributes, they are actually easy to read and kind of easy to understand what they mean. Most of them, at least. Then we have a sphere that follows the same approach, and then a cylinder, and then a plane. And then we have actually something that is not very easy to see here in this example, but we have a sky. So a sky is a special primitive that kind of fills all the space around you. Actually, not just on the sky, so it's kind of like a sphere. It's kind of like you are inside a sphere and the sky is the inside of that sphere. And so in this example, we are saying that our sky, it has this color. And this color is a gray color. So it can fills the space very far from us, but all around us. And so you can see, I'm kind of getting a bit ahead of this the chapter, but just to explain these elements, you see that we can specify color in different ways. For example, on the box, we said the color is red, but on the spheres, for example, we say the color is this hash code. For the design students, at least, this is obvious what it means. It's a color code, an RGB color code in hexadecimal. For the history students, maybe not so obvious, but this is just one way of specifying colors. In computers, colors we have a number of different color models, but perhaps the most often used one is the RGB, red, green, and blue as the primary colors, and we just mix different parts of these three colors to achieve any imaginary color. And these values are sometimes written, instead of we writing them in decimal, which is the way we naturally count from 0 to 9. Sometimes in computers we use hexadecimal values, so we count from 0 to 15. But because we don't have single digits for the numbers starting at from 10, 11, 12 up to 15, we start using letters. But kind of it's just a number. And you don't have to worry about this, so you don't need to write this by hand. Actually, if you want to find a color, you can just Google color picker, for example, or use one of many softwares that allow you to select a color, any color that you want, and then you can just copy the hexadecimal value back to A-frame. So you don't need to actually know how to code colors. So an additional piece of terminology that is also important when we talk about A-frame is that these attributes, in A-frame, they have a specific name. So in the context of HTML, we call these attributes. In A-frame, we call these components. So it's a different name for the same thing, or roughly the same thing. Just so that you know, if you read additional stuff about A-frame, you will see this word components. In practice, components are written as HTML attributes. Again, just to make this, to try to make this perfectly clear, you don't need to write all the attributes on their own line. So if you write them all on the same line, for example, like here, it will also work. You just have to make sure to allow to give at least one space between the attributes. So here there's always one space, but you don't need to break the line. You don't actually need to hit the enter key on your keyboard. You can write everything in a single line, but if you do this, then the lines will be very long, and so it's sometimes easier to format the texts like this, but the browser doesn't really care. Okay, now let's see some of these in a bit more detail, because and by the way, this is, I think, the first obstacle, the first difficulty that most students, I think, find when dealing with A-frame, which is what do those numbers mean in relation to the position or rotation. And so I told you that the values, the units in A-frame, they are meters. So that kind of, we use a natural scale for us. So we think in meters, we think in distances in meters. And this is easier, I think, than thinking about in, for example, in millimeters or pixels. But we still need to know a bit more about what the position means. So let's see, when we write something like this, for example, on the example above, we had position equals, I'll go back for the box, position equals 0 space 2 space minus 2. So what does this mean? This means that the center of the box, of that primitive, that red box, is placed on a reference. And so this reference is composed by 3 axes, the X, the Y, and the Z. And the order is always X, Y, Z. It's always on this order. And so we are saying that on the X-axis, the box is kind of displaced by 0. So it's not displaced, it's exactly on the 0 value of the X-axis. On the Y-axis, it's displaced 2 meters in the positive direction, and on the Z-axis it's displaced 2 meters on the negative direction. But what is the reference frame? So this is a very important thing to understand. When we enter, I'm going to reload this. When a user enters the VR environment, his feet are placed on the 0, 0, 0. So the feet of the users is on the 0 X, 0 Y, and 0 Z. The user's feet. So because we have some height, the user's eyes in A-frame, when we look through a desktop, the user's eyes will actually be on the Y 1.6 meters. So A-frame assumes a kind of an average height for users that is 1.6 meters high. And so this is the reference frame. You should think about putting objects kind of around the user. So the reference frame is the initial position of the user, and his feet, his or her feet, are at 0, 0, 0. And how do the axes relate to one another? Here you see a picture of the axis. So you see that the x-axis, when you are looking into the screen, the x-axis grows to the right. So to the right is the positive direction, and to the left is the negative direction. The y-axis grows upwards, so positive y is upwards, negative y is downwards, and the z, it grows from the screen towards you. So the positive z is from the screen towards you, and it's negative away from you. I usually prefer another way of remembering the axis, which is kind of the right hand mnemonic, which is depicted here in this picture. This makes it easier to remember. It's hard for me to do this on the camera, but you just have to open up your thumb, index, and middle finger, and point your middle finger towards your face. If you do that, then on kind of the natural order of the fingers, so the thumb is your x-axis, your index finger is your y-axis, and the middle finger is your z-axis. And so if you point the middle finger towards your face, you have the positive direction for all the axes, because that's the direction your fingers are pointing to. Okay, so the negative is just the other direction. So this mnemonic, I think, helps a lot to position things. Then we have the size. So position is one of the attributes, one of the physical attributes of our 3D objects, but we can also change their size. And for the size, it actually depends on the object that we are placing. So a box, for example, it has 3 dimensions. It has a width, a height, and a depth. And here they are written on the order that is associated with each axis. So width is associated with the x-axis, height is associated with the y-axis, and depth is associated with the z-axis. If you are placing a sphere, then you don't specify a sphere in terms of width and height and depth. You just say what is the radius of the sphere in meters. If you are placing a cylinder, then you use both height and radius. So the way to specify the whole size of an object depends on the object itself. But as you can see here, it's kind of a familiar way, a natural way of specifying the dimension of each object. Again, if you are trying to use a primitive that you don't know, that you have not used before, then you should look for it in the official documentation. For example, a plane, and just see the examples and see how you can resize the plane. So for example, a plane we see here, it has a height and a width. Okay. Then we have rotation, and rotation is also a bit tricky. So basically, rotation allows us to, well, first before that, each object, if you don't specify a rotation, when you put the object in the 3D environment, it will kind of have a default orientation. So we can see here, for example, that the box, when we place a box in our environment, it has a kind of a default orientation. So one of the faces of the box is facing towards the user. So it's default rotation. But we may want to change this. For example, maybe we want a corner of the box to be facing the user. So in that case, we have to rotate the object. And to rotate an object, we need to specify 3 rotations actually. So we need to specify the X, Y, and Z rotations. Of course, if we just want to rotate on one axis, you can just specify 0 for the other ones. But we still need to enter a value, even if it's 0. So we need to think about rotations in terms of which axis is the object rotating around. And for example, let's say maybe I'm going to make a change perhaps in one of these examples. So I'm going to open here the source code, and I'm going to repeat the steps that we did last time. So I'm looking at the source code of an example. I'm going to copy it, and I'm going to open up my project in A-Frame, an empty project or almost empty project, and I'm going to paste and change that example. So I'm going to here create a new file, and I'm going to call it rotation.html, and I'm going to paste, and I'm going to first I'm going to change this back to 0 on the rotation. So we are trying to work out the rotation of the object. So I'm going to put it at 0, 0, 0, and let's preview this. So examples and rotation. Okay, so now we have a box, and you see that so it's a very tall box, and again it's on its default orientation. So one of its faces is facing the user, but maybe want one of these. I want this edge to face the user instead of this face. So we need to rotate the object, and we need, in this case, what we need to do. We need to rotate the objects about 45 degrees around which axis? Around the y-axis. So I want to rotate the object around the y-axis on 45 degrees. So I'm going to write here on the y-axis, so it's the second value actually. So I'm going to write 45 degrees. So on the rotation, the unit is degrees. So we can rotate from 0 to 360. So I'm going to reload now. And now we have the edge facing the user. So we rotated on the y-axis by 45 degrees. If we wanted, let me make a few other changes here before we go back to the chapter. Of course, we can rotate around any axis. We can rotate 45 on the x-axis. So if we reload now, the box is rotated on the x-axis, and for us to understand, so it's kind of tilted towards us. And of course, we could rotate it also on the z-axis, and we can combine. So we can write a rotation of 45 on the x and 45 on the y. So we can combine several rotations into a single one. So that now the box, as the user enter, it's rotated on the y and simultaneously on the x-axis. So, but this is not when we start writing A-Frame. This is not very. It might not be very intuitive. What I think may help again is a right-hand mnemonic to think about how much or at least in what direction will the object rotate. And the mnemonic you can use is, so again, the right hand mnemonic, but you need to use this kind of for each axis that you are trying to rotate. Because one of the problems is, okay, so let's say I'm going to rotate instead of, let me write here a different value. So instead of 45, I'm just going to rotate 15 and see the result. And so it's just rotated. I'm going to maybe increase a little bit so it's easier to see. So rotation on, and I'm going to change this. I think it's easier to see on the y-axis. So I'm going to reload. So the box is a bit rotated on the y-axis with by 25 degrees, but the the difficulty is, okay, but in what direction am I rotating the object? Is 25 degrees rotating on this direction or on the opposite direction? So one of the mnemonics that helps in this case is doing the following. So you know in which axis you want to rotate. So let's say I want to rotate on the y-axis. So what you do is you point your thumb on the positive direction of the axis you want to rotate about. So I'm rotating on the y. The y grows upwards. We know that by the other mnemonic. So the y is this one, it grows upwards. So I point the thumb upwards. And now the direction that your hand naturally closes is the positive rotation direction. So if I rotate 25 degrees, the box will rotate on this direction. And of course, you know, if we rotate minus 25, then it will rotate on the other direction, the hand, on the direction that the hand cannot bend. So you just rotate to the other side. So I think this, at least initially, this may be a good mnemonic to learn how rotations work, because it's not very easy to understand. Another thing, kind of another physical characteristic that we can manipulate in A-frame in our objects is the scale. So this is kind of an alternative in some situations. So the scale allows us to resize an object along its three dimensions, x, y, and z, independently. So, for example, we can write the scale 1, 1, 1, and scales work by as multipliers. So 1, 1, 1, a scale of 1, 1, 1 means that we are multiplying the size, the x dimension of the object by 1, the y dimension by 1, and the z dimension by 1. So multiplying by 1 actually does nothing. So this is a scale that does nothing. And a scale of 0, 0, 0 will make the object disappear because you are multiplying by 0. But of course, we don't usually use these values for scale. We use values different from 0 or 1. So for example, we can, I'm going back to one of these. So to this example here, I'm going to put the box with its default dimension, so it's easier to understand what the scale is doing. So here we have a box. Oops, with the depth. Okay, so here we have a box that is actually a cube. So 1 by 1 by 1, and the scale. So I'm going to write here the scale. It kind of allows us to multiply those dimensions by a different value. So for example, I can write scale, and let's say I want a box that's twice the height and depth. So I just write 2, I want to multiply the width by 2 and the height by 1 and the depth by 1. So multiplying by 1 will do nothing. So the box will just grow horizontally. So now we have a box that is twice the width uh, than its height and depth. And of course, you see from this example that this is an alternative. So I could have created the same box by writing 2 on the width, 1 on height, and 1 on depth, and not using the scale. So this will create the same thing. So in some situations, scaling is an alternative. In other situations, it's the only way to achieve a desired effect. So I'm going to change here the box. Instead of box, I'm going to use a sphere. So I'm going to change box to sphere. And I'm going to remove the rotation and the width and height and depth, because a sphere has a radius. So I'm going to write here a radius of a 1. No, I'm going to write 0.5. So a radius of half a meter. And I'm going to preview. And so now let's imagine we wanted to deform the sphere. So now we have no alternative, because I can change the radius, but it will always be a sphere. So it will be a larger or smaller sphere, but it's always a sphere. But if I use a scale, now I can scale, for example, 2, 1, 1, and so the width of that object will be distorted. So scaling allows us to deform objects. And in some cases like this one, like the sphere, it's the only way to achieve this effect. Okay, so scaling can be an alternative or the only way to create a given specific shape. Again, scale works a bit like position or rotation, so you need 3 values for the x, y, and z. And then we have color. So this is kind of the last physical characteristic that we can manipulate, or that we want often to manipulate. We already talked a bit about this, so I'm not going to spend much time here. Again, just to remember that for colors that have a name, we can use that color. I'm going to open here the source code of this example. So you see here that we are using color names, so red, green, and blue. But if a color doesn't have a name, then we can just use the hexadecimal value. So the last thing to, or the last actually 2 things to know is first that we have additional primitives beyond boxes and spheres and planes. There are a number of kind of different shapes that we can create. And this example here, it shows, I think it shows all the default primitives that A-Frame offers. I'm going to open it here so that I can show you. So you have, some of these are weird looking shapes. So for example, like this one, the kind of a donut, or this one, and then other kind of solids, regular solids, so 3D objects. So you see, we also have the more simple ones like the cube, a cone, a cylinder, a sphere, and we also have, and this is also important to note, we have objects that are actually 2D objects, but that we can place on a 3D environment. So for example, here we have a circle. So it's a 2D object, but we can place it in 3D. We have the plane we already saw. So a plane, in this case, it's squared. Uh, so also the ring, also a 2D object, and a triangle. So there are a few 2D shapes that we can kind of place floating around in 3D space. And so if you want to use one of these, then you can just refer back to this example and see what is the name of the primitive. The last thing to note about primitives and structuring the 3D world is about nesting the primitives, or placing one object inside the other. And sometimes we want to do this because it makes it easier to place things. So let me try to give an example where this is useful and explain why this happens. So let's imagine this situation here. I'm going to load this and move a bit around. So imagine in this case, or actually I'm going to open this in a new tab to make it bigger. So imagine we have this situation where we, for some reason, let's not worry too much about that. For some reason, we want to place a circle with a sphere on its edge. And so of course we can do this in many different ways. So let's first try to do this in one way. So I'm going back to I'm going actually to copy this code, and I'm going to reuse this. Actually, I'm going to create a new file. I'm going to call it nesting.html. I'm going to paste that example, and I'm going to do this a bit differently. So we have a circle and we have a sphere, and let's preview this. So oops, I have to close this and open again so that I can navigate to that example, to the nesting one. And so let's position the sphere on that edge of the circle. So how can we do that? So we know that the circle has a radius of 1.5, and we know to make actually let's do this in a in an easier way to start. Let's place the circle on the 0, 0, 0. And I'm going also to place the sphere on the 0, 0, 0 to make it easier to see. And actually, this may be an approach that maybe you want to follow when you are trying to create your own stuff. To try to position things on the origin to make it easier to understand how they move. So I'm going to reload. And one thing is going to happen, that, and this may seem strange. So we know that in our scene we have two objects, the circle and the sphere, but when we preview, we see nothing. Why is this happening? Because 000 is at the user's feet, and the user is looking forward. So it is not looking at his feet, so it's not seeing our objects. So to see the objects, we need to move back. So we hit the arrow keys and we move back. And then we see the circle and the sphere. But we want the sphere to be on the edge of the circle. So how do we do that? Well, we know that the radius of the circle is 1.5. So we can position the sphere at 1.5 on the x-axis, for example. And now we move back and the sphere is there on the edge. So this is one way of doing things. What is the problem with this approach? Well, imagine that I don't want the circle to be at the user's feet. I want the circle to be in front of the user when he enters the world. So we need to move the circle. So let's move the circle to a position where it's in front of the user. So if it's in front of the user, it means that, again, using that kind of right hand mnemonic, in front of me, it means that the z-axis, so the middle finger, we need to position the object beyond the z equals 0. And because the z grows towards us, we need to give the object a negative z. So for example, let's position the object 2 meters in front of the user. So this is -2. Also, to really make the object in front at eye level, let's use a y value of 1.6. So 1.6 again is the height of the user, or at least the eye height of the user. So the circle will be centered at the height of the user's eyes. So if we reload, now we have a circle in front of us. What is the problem? The sphere is not there because we just moved the circle. So now we need to move the circle also. So we need to move 2 objects. So let's try to do that. Let's move the y of the sphere to 1.6 and the z to -2. And now it's there where it's supposed to be. But we needed to move 2 objects. And so in these situations where we want objects, we're trying to create kind of a more complex object by using smaller ones, but our intention is that this is perceived as a single object. In those situations, it makes more sense to place objects inside one another. And I'll do that now, and I'll explain why is this easier to do. So let's instead say that the circle is kind of our main object, and let's put the sphere inside the circle. So notice here I'm going to add a few empty lines to make this easier to understand. So we have a circle, notice the opening tag, closing tag, and the content of the circle is now a sphere. Now this does one thing that is not obvious. When we place an object inside the other, the reference of the inner object is no longer the user's feet. So the reference is no longer the main reference for the whole scene. For an object inside another one, the reference, the 000, is the main object, is the outer object. So I'm going to put here 000. Remember, in our first version, 000 on the sphere would put the sphere at the user's feet. And now let's look at where it is. So notice that 000 for the sphere now put it right on the center of the circle. Okay, this is because the sphere is now inside the circle and not outside. So if I move again, just to make this perfectly clear, I hope I'm going to move the sphere out of the circle and reload the example. and now the sphere will be at the user's feet. So it disappeared from here, and to see the sphere, I'm going to move back. And eventually there's a sphere. This is where my feet were when I loaded the scene. So I'm going to put this back inside the circle. Now this is actually, it's kind of feels strange initially, but it makes it easier to position things relative to one another, because now I know that the sphere is positioned relative to the circle. And so if I want it to be on the edge, I just need to add 1.5 to the, for example, to the x-axis, because I know this is the circle's radius. So now I'm going to reload, and it's right back at the position where it should be. By the way, to answer a question, the unit in A-frame is meters. It's not millimeters, it's not centimeters, it's meters. Okay, so here, for example, 1.5, this is 1.5 meters. Or here, the radius of that small sphere, this is 0.1 meters or 10 centimeters. So for one, putting an object inside the other in many situations makes it easier to position because it's relative to the outer object. The second advantage is that now imagine we don't want this complex object to be right in front of the user. Maybe we want this to be a bit to its left side. What do we need to do? We just need to add something to the x-axis, or subtract something, because the x grows to the right. If we want it to be on the left, then it's minus something on the x. I'm going to write -2. But now, because the sphere is relative to the circle, I don't need to change the sphere. It will be positioned correctly relative to the circle. I'm going to reload, and the circle and sphere will have moved together to my left side. Okay, so now it's easier to make changes when we have objects inside other objects. But this is something, it's not completely obvious, so this is something that needs a bit of practice. So actually this first part where you try to create a mental model of how things work in A-frame, I think is the hardest part. And so I think what's best for now, because I have finished this chapter, I think we should do perhaps the following. Instead of me moving on to a different chapter, because I think that will be too much right now, I think it would be better if maybe for the next hour or hour and a half, you look at these chapters 10 and 11, particularly this 11 one, and you try, and maybe you go through the chapter again, and you try to make the changes that are suggested in these tryout boxes. There are a few of them, a few tryouts, and then you try to at least to solve the first exercises. There are 5 exercises, but if you solve perhaps the first 3, that would be already nice. And this will give you an opportunity to practice positioning things. Again, don't worry for now that these examples, they create kind of very simple, kind of abstract environments. Don't worry. This is how we get into things. So we are starting slow and creating things that are very abstract, and they have no meaning. But this is to practice positioning things and rotating and stuff like that, and getting a bit of experience with A-frame. So I think you should now do these exercises and um, tell me any questions that you have while you are solving those exercises. And then, well, in 20 minutes, we will do a break for dinner or lunch. And then you can continue solving the exercises. And then at the end of the session, if we have time, I will go back to the chapters and talk a bit about text. Is that okay, Bayo?
Okay.
Okay.
Okay. So I'll be here. I'll just turn off my camera so that you don't need to keep looking at my face while solving your exercises. But I'll be here, so just write on the chat or speak, and I'll hear you.
Okay. Should we upload or?
Yeah. Well, you should solve these tryouts and exercises in your project. So you should create, maybe you can create a folder for the tryouts, and you already have a folder for the exercises. So maybe you can separate things so that then you can deliver the exercises.
Okay. Yeah. Okay. 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 Got it. Thank you.